question, negative 9 times 1/3. So I'm going to just rearrange it and put negative 9 times 1/3, keeping in mind that that is negative 9 over 1. So this really is just negative 3 times underneath my square root. I might start looking and going, oh, 28 times 63 is going to be a huge number, not going to multiply it. So how can I factor 28 as 4 times 7? Then I have an a squared, so I'm going to keep a squared. Why not multiply it with an a to the first? Because in order to find this square root, it always has to be an even power times an odd, or just an even power underneath the square root to find that. So now I'm going to look at 63. How am I factoring 63? What are factors that you can think of? 9 times 7. And then you still have this a. All of that is underneath that whole square root. So we simplified to get negative 3. The square root of 4 is 2. I got another one. The square root of 9 is 3. Oh, I have 7 times 7. 7 times 7 is going to be 49, but the square root of those two together, remember the first day of the video, we can just pull that out, and that is simply 7. The square root of a squared is a to the first. The only thing I am left with underneath that radical is an a. So I am going to multiply in 31, negative 3 times 2 times 3 times 7. That is how they got the negative 126a square root a. When I take a look at number 33, again, I'm not going to write the whole problem because it's written up above. 1/3 the square root of 18. And I might put my 1/3, and I might put right away, since back here is times negative 6, I might put 1/3 times negative 6, negative 6 over 1. Negative 1/3, thank you. Then I'm going to put my square root. I start off with 18. What's a perfect square that goes into 18? How about 9 times 2? And I have c to the 5th and c to the 9th. Well, c to the 5th times c to the 9th, going back to our last unit, what do we do with exponents when we're multiplying? So I'm going to have c to the 14. That's for both c's. And then in this last one, I have, Benson, I have 8, and how are we going to factor that to a perfect square? Perfect square that goes into 8. 4. So we're going to put 4 times 2. All of that is underneath the square root. Did you already have this one done? If not, make sure you're writing it down. So, negative 1/3 times negative 6, that is simply 2. The square root of 9, 3. The square root of 4, 2. Oh, I have square root 2 and 2. Since I have 2 of those, that is the square root of 4. That's another 2. The square root of c to the 14th, I divide the power in half. It is to the 7th power. So I am now going to multiply 6 times 4 to get 24c to the 7th. If you did not do the work. 13, and I'm going to look in on page 13 notes and say, oh, why isn't this one? Because this has what in the denominator? It has a radical. So your reason would be not simplify because it has a radical in the denominator, right? So you are going to give a reason for each one of these, okay? They say, explain why it is not in simplest form as we are looking at those. Okay, that's what your G6 for on page 16. In your textbook, this is 10-2, and it's simplifying radicals by removing perfect factors and then dividing them. So radical expressions are expressions with radicals. Ones that are simplified, the following statements are true. No radicand or radical, so no perfect factors in it underneath there. So this one, square root 6, is simplified. What we talked about, the square root of 12 is not. Square root of 12, you can factor that as the 4 times 3 and get 2 square root 3, okay? 6 can't be. The radicand has no fractions, so when we think about that, underneath here, we can't have square root 49. And there are no radicals in the denominator or the fraction. So a radicand with a fraction can always be split to the numerator and denominator. Square root of 36, we know that is 6. Square root of 49 is 7. So when you have two numbers in that fraction underneath the radical, you want to split it apart. So they don't always go real easy, but some people get really confused when they look at this and they go, oh, 8 divided by 50. What's a common factor that goes into both 8 and 50? 2, right? We can divide them both by 2. So that's what they did. They looked at 8 and 50 and they divided them both by 2. And they went, oh, 8 divided by 2 is 4x squared, and 50 divided by 2 is 25. How do they get rid of x to the third to x? They use our exponent rules, right? So simplifying just underneath that square root, x to the third, when it's division, you're subtracting. So they have x squared. Now we want to break it apart. In the numerator, we have 4x squared. The denominator, square root of 25. The square root of 4 is 2. The square root of x squared is x. The square root of 20. And this is my simplest form. So sometimes it's better to simplify the radical first before trying to take your square root. So sometimes it's easier to just take the square root. Square root of 144, you guys memorize that, is 12. Square root of 9 is 3. This can be simplified further. What is 12 divided by 3? 4. So your answer is 4. Now, could you have divided this right away? Yes, I probably got 16. This is the square root of 16, which still gives us 4, but it's just as easy to find each of these. So here, we want to simplify. We could find the radicals and subtract them, right? Divide. So we got 4 over 36 is equal to what? 9. I have a to the first over a to the third. Where is my variable going to end up? Numerator or denominator? Denominator. We are subtracting, and so in the denominator, I'm going to have 3 minus 1, which gives me a to the second. I now want to take the square root of 9, which is 3, over the square root of a squared, which is a. Yes? How many times does 4 go into 36? 36 divided by 4. I simplify it. Is there a different way of doing this one? Yes, so here's what you're thinking. So my answer is 3 divided by 8. Could you have done it this way? Could you have said, oh, the square root of 36 is 6. Keep that as square root a, right? And this is 2. Do you agree that 6 divided by 2 is still going to give me 3? Yeah. And now I have a to the first and a to the third. So I would have 3. And this would be times the square root of 1 over a to the third. A to the second. To me, this is much easier to do it this way than to keep breaking it apart. I am going to divide 36 by 4. So there's more than one way to do it when you look at this. So I look at this last one. I have m to the 3 and n to the second, not the same. But I can find the square root of 25. Square root of 25 is 5. I'm going to factor this m to the third to be m to the second times m, right? Because when I take the square root of m to the second, it's just m, and I'm left with square root m. And in my denominator, the square root of n squared is n. And that's my answer when I'm looking at the problem, okay? So I'm going to leave it like that. You can have a square root in your numerator, you just can't in any of your denominators, okay? As you take a look at this next one, it says rationalizing the denominator on top page 17. It says when a radicand is in the denominator, it is not a perfect square. So underneath your square root, it is not a perfect square, and that's in your denominator. It says you may need to rationalize the denominator or remove the radical. To do this, you multiply the numerator and denominator by the same radical expression. Choose the expression that makes the radicand in the denominator a perfect square. So you're always going to look at what's in the denominator and multiply it so you do not have square root 7. You need a perfect square. It says it may be helpful to start with simplifying the original radical first, as we are looking at that, and then simplify your denominator. So square root 3 over square root 7, this is how they started the problem. They said, all right, I have square root 7 in my denominator. I need to get a perfect square down here. So I have to multiply the numerator and the denominator by square root 7 over square root 7. Why? Square root 7 divided by square root 7 is the same as 1. So you can multiply a numerator and denominator. It's just like simplifying fractions, or multiplying 1/2 times numerator and denominator both times 5. 1/2 is the same as 5/10, right? Is the same as 4/8, and you can simplify it. That's what we're doing here. We now get the square root of 21 divided by square root of 49. This is my fraction simplified. It's called, you're rationalizing, it's called the denominator. This next one, we look at square root 7 over square root of 8n. So I'm looking at just the denominator to try and rationalize. The numerator stays. How did they get 2 square root 2n? Because when you look at the square root of 8, they said 4 times 2n. The square root of 4 was 2. What do I have to multiply by to rationalize this denominator? Square root of 2n. You have to do it in both the numerator and denominator. 7 times 2 gave us 14n. In our denominator, I had 2. And when I multiply those two together, I get 4 and n squared. The square root of 4 is 2. So 2 times 2 is how they got 4. The square root of n squared is simply n. So it says, it's a similar idea of changing fractions in order to get a common denominator. Instead, we always want a perfect square in our denominator. So this is key as you look at this. In our denominator, we have what? Square root 3, right? Not 3, right? Square root 3. I need to rationalize it. Brody, what am I going to multiply both numerator and denominator times so that I can simplify that? I need the bottom to be a perfect square. So I have square root 3. What can I take it times? Not 3, but times square root 3. So please, everyone, make sure you write down times square root 3 over square root 3. If I'm multiplying that in my numerator, Angus, I am now going to have the square root of 6. And in my denominator, I am going to have, Owen?
Square root of 9.
Square root of 9. I can find the square root of 9. Wyatt, it is 3. So in my denominator, I have 3, and I'm leaving this as the square root of 6. Now, you cannot divide this and say 2 divided by 1, or square root of 2 over 1. Because if you put the square root of 6 in your calculator, it is not equal to 3, and 3 is not divisible into that. That's an irrational number. Never ends and never repeats. We're going to look at this next one. As we look at that second one, in our numerator, we are going to start with square root 5. We're going to leave that. But our denominator, Henry, how are we going to factor? Perfect square. Okay, 6, and neither one of those is perfect. Go perfect square. 9n, 2, and then we have m. So if I'm doing that, Maya, how can I simplify that denominator? I'm going to have square root 5 over what? What is the square root of 9? 3. And I'm left with the square root 2m. All right? So, if I'm looking at this one, as I now want to simplify, Caleb, what do you think I'm going to multiply both the numerator and denominator by? So what is underneath my square root in the denominator? Not just 2, but what? 2. Yes, and so when I multiply, I have to multiply by the square root, not just 2m, but the square root of 2m. That works out kind of nice in the numerator, as I am looking at that. Tristan, what do we get in the numerator? Square root of how much? 10m. Yep, we're going to multiply, not add. Okay. My denominator, I have 3. 3, Evan, times what? 2m. Because 2 times 2 would give us 4. So since I have 2 of those underneath, the square root of that is just 2. The square root of m times m would be m squared, and I'm left with just 2m. So I am now going to leave my numerator as square root of 10m. And then in the denominator, if I'm looking at it, Emily, I would have 3. I'm going to multiply those.
6m.
6m. So I have the square root of 10m. All of that, one thing, make sure you extend that square root so I know that both of those are underneath there. And in our denominator, it is simply 6f. We are going to break it apart as the square root of 7f divided by square root 3. What do I need to multiply both numerator and denominator by to get rid of my denominator square root 3? Multiply both sides by square root 3. Emma, when I do that, in the numerator, we have now what? 21f. And in my denominator, if I'm looking at that, I'm going to have the square root of what? 39. So my final answer, Lulu, would be? So always have some go. Can't 21 to be divided by 3? They're not both underneath the square root, so that you cannot do that. Whereas when you looked at like this, what was the one that we gave originally? Right here, 36 and 4 were both underneath. You can divide both of those if they are both underneath that radical right away. Angus, question? Okay. So they both have to be underneath, and if you could simplify, like if this would have been 21 over f, then I would have simplified that, but it is not. So your homework is on the workbook G6. You should